All right, so this slide here, this page is our website, RVCR code. I've already went over, I believe, almost all the announcements for that. Let me click the home button here just to make sure I got it all. And the RVCR code is a place, all things coding, robotics, techie, geeky events is going to be on this website. You'll see all the images of past hour of codes, past events. So avail yourself to that, bookmark that if you've not already. For this week, we're going to be looking at week 2, the little picture of computers connected together representing a network, kind of like the handout I gave you. We'll be going over that in our discussion. Also we'll go over the due dates here in just a second, right now, before we get into the discussion. So we're going over chapter 1. We'll do the in-class lab right after chapter 1 discussion. I think I told you in week 1, I'll ask you guys at the end of discussion, do you want a 5-10 minute break? If you do, it'll be a consensus vote. We'll take a break. If not, we'll just rush right through and go right to the lab. It's up to however you feel. Okay, it'll be majority vote. If you do need to take a break and go to the restroom, though, it usually takes a couple minutes to shift and get everything ready for the lab. So if you do need to slip out to get a drink at the water faucet or restroom, down in the basement is where you'll find the pop and water, which you can definitely bring in here. Just keep the lid on it. And, I don't mind you keeping it on the tables. I did clean all the tables in here last week and monitors. They were supposed to have vacuumed, but it doesn't look like they did. And so just try to do your best to, keep it on the table and you're fine. Tonight's podcast will be where that's at now. That's the last semester's. In fact, if you look ahead, you'll see podcasts, and those are from the last time I taught the course, which was last spring. But I just leave them in there because I know students kind of look ahead and want to go, see what's going on in the next week. This slide here, Lab 2, is what I gave you in the handout. But again, you can look ahead even in week 3 of next week to see what we're doing. And you can open up that document and see what we're doing. By the way, on this one here, before I forget, which I always do, into lab, if you could do me a favor, and submit and just type in your name in the text box entry. You do get 50 points for the lab just for being here, but remind me if you would, somebody, each week to do that, because I try to do it right at the beginning of class, that way you don't forget. Because some of the labs I have you disconnect from your computers and it's a hassle to go back in and do it later. So again, in 2 lab, just submit your name, that's all you got to do. Review questions, while you're doing that, I'll go over review questions. In the back of each chapter of your PDF textbook is review questions. And I just need answers only. So an example, most of them are multiple choice. So off the grid of the internet, I suggest doing your questions. I've had students do it on their phone, and that's fine, in a note document or something. And then after you're done, paste it in Eagle. And so an example like 1A, 2B, 3D, so on and so forth. Make sense? And all you need to submit is that type of format. All right? And again, don't do it, though, live in this interface. Like, don't hit submit, type in your answers, because it'll time out in about 10 minutes, roughly. And it's supposed to save your work, but I've had students tell me it doesn't. So I don't trust it. So I'd say do it off the grid. That way, when you're finished totally, you can just paste it in there. Make sense? So that's review questions worth 20 points. And each week you'll have review questions. And each week you'll have a lab. Next is quiz. You'll get 3 attempts. It's on Chapter 1, Introduction to Networking. It's worth 28 points. And you'll get the highest score out of 3. Each time you attempt the quiz, you can go back after each attempt to view the answers if you want to, but it does force you back in your text that first time around for sure to figure out where things are at in your book and answers and things like that. And then research paper topic. The link on the research paper topic, I think we went over in week 1, did we not? You're going to choose a research paper topic, which some of you have already talked to me about what you're thinking, especially if you chose the other line at the bottom of that document. There's an other. So I think I told you to Google the names if you didn't know what they were. And, you might look at one and go, whoa, that's kind of cool. Choose a research paper topic, and all I need you to submit in here is the topic, and it's due Sunday. All right, questions on that? And again, if you have a question about a topic you're thinking of before you leave tonight, just come and see me. If it has anything to do with networking, I'm gonna let you do it. I like people to push the envelope. So if you want to do something a little edgy, or like, I don't know if this is really fitting with computers and networking, let me know. If it has anything to do with networking, like I think I told you last week, one of the most envelope pushing ones I've had recently was a student wanted to do networking as it pertains to social media and how people share files and the security ramifications or lack of security ramifications you have in sharing documents in social media. So, questions on that? Research paper? All right, cool. All right, so looking at now some of the objectives of the chapter is some of the advantages of network computing over standalone computing. In this generation, pretty much this generation when I say this generation, students, 25 and under, you don't know anything but networking. You've always worked in a networking scenario, networking computer scenario. But I remember when we didn't have networks and where we just started getting networks and had, standalone computing where I was literally by myself. Anybody else remember that in here? Any old geezers like me? Okay. All right. And so it is kind of interesting to see and to talk to younger folks about networking, because you're like, yeah, networking, been there since I've been walking around, right? And so, but to understand networking, the intro to networking, you have to kind of understand where we come from, to appreciate where we are and where we're going. And believe it or not, we're still like in the infancy stage when it comes to networks and internet, believe it or not. We're still in the infancy stage with speed, with security, and you think it's bad now, or it's really rough now, or really scary now with networking and security. It's going to get worse because the speed of growth in computers and technology and internet and security is exponentially getting faster. So what used to take 6 months to a year for something to change in technology now takes days to change. And that gap's going to even get closer and closer. So I always tell students in this week, if you are a person that loves change and you love to adapt to change and you love to keep on top of current events and figure stuff out, you will love networking. You will love anything to do with computers, networking, and technology. If you like things the same once you've been trained, you probably won't like to get into computers and get into technology because it's constantly changing. And so when I'm teaching something like this semester and even my other classes, a lot of the stuff I'm teaching that's outside of the book is stuff I just learned in the last 6 months that I'm starting to use, okay? There's not really a lot of fields like that, if you think about it. Medicine will be another field that's like that for sure, but not many other fields that changes really drastically like that. So one of the first things is understanding the differences between client and server, what a peer-to-peer is. We did a little fun poll last week, which hope you had fun with that. We'll do that again, by the way. And then look at the commonality between client and server architecture. Most of you are familiar with clients. We'll talk about that this semester, but you may be not familiar with server, okay? Totally different in a lot of perspectives, and software would be one of them, totally different, and how they function. So we'll look at some of the different uses for networking, certificates available. There is a certificate called Network Plus, which I do recommend. CompTIA is one of the testing facilities we have in the U.S. and abroad that you can get certifications. And it's a middle-of-the-road certification. It's not Cisco, it's not Microsoft. It's Network Plus. It's kind of a middle ground certification. Students do get a discount for certification. And if you fill out the right paperwork, you can even get it for free. What it is for free is they just follow you for 5 years after you've graduated to see how you're doing, see what kind of job you have, all the good stuff. But it's kind of cool. And so a lot of students aren't aware of that. And we do the testing on campus in the testing center. So if you are interested in Network Plus certification, there is information of it in the back of your text. Online, if you just type in Network Plus, you'll see more information as well. But I can hook you up with study guides to help you study for the test. And they have these little online tutorials you can do and online testing you can do. And they do what's called progressive testing. And what that means is, say you're in taking an area of networking in a test. If you're acing an area, out of 2 or 3 questions, you ace them, they'll skip to another category. And if you start missing questions, they'll really give you more questions in that category. And so they kind of progressively get harder on the things you're weak on. And so the testing that I recommend, or the prepping, is the software I give students, the online software. If you get up to 85, 90 percentile on your testing, you're ready to take a test. All right. I don't really recommend taking it during semester with your full class load. I tell students to do it over the summer. It takes about a month to prep for it if you have no other classes. And then some students less than that, but about a month to prep for it, and then you can go and take the test. And so if you're interested in that, let me know. But there's tons of certifications besides Network Plus. We do offer here on campus Cisco courses, which can help you with Cisco certification, CCNA, and things of that nature. We'll also look at some of the skills and specializations involved in networking today. So why use networks? Well, I'm glad you asked. It's a group of computers or devices that are connected by some type of transmission media. A year and a half ago, mobile devices surpassed sales of laptops and desktops for the first time. So everybody in here and where you work, a lot of people use mobile devices, right? And what type of media, how do you connect to the internet with those devices? Anybody tell me?
4G connection through
Yeah, so cellular, right?
Or Wi-Fi.
Cellular, Wi-Fi. Any other that you can think of?
You could get some like files through Bluetooth.
Yeah, Bluetooth, you could share some stuff, right? And so, a lot of different computers today, when you think of networks, you don't really think of mobile, but mobile is a big part of networking now, and a huge part of networking. Laptops, desktops have really gone down in the spectrum on everyday business use. And if you see meetings or if you go on the road, a lot of times folks are carrying tablets and phones, and that's it. That's all you use. But still, they're a computer. All right, still a computer, still a device. But the media, the transmission media, is not wired now. At the most part, it's wireless. Okay, like all your computers here are wired with if you look at the back of the room, those white cables on the wall back there, all of your computers are connected with those white cables, which are called Cat5 cables or straight cables. And they go from your computer to the back of the room. There's 3 gray boxes. They're plugged into those boxes, and then those are called switches in those boxes. And then up here, we actually have this little blue box here is a Cisco PIX router that gives us the ability to have internet and network connectivity in a classroom. And then from that little PIX box, in this gray box here, there's a fiber optic cable, which is another type of cable you'll learn about this semester, that runs through the floor to the server room over here in IT, where it's finally connected to a server in there. So networking is connected computers. It could be wired, wireless, Bluetooth, a whole bunch of different RF technology. You could even say AM, FM. You can transfer stuff that way, believe it or not. Not just radio, but even files in a small fashion. Standalone computers. This is what most of us, in my generation anyway, started with. Okay, standalone computer. My first laptop was 65 pounds. Okay, it was an IBM, and it had a keyboard, regular size keyboard like you guys have in front of you, that's set in front of the, when I set it on the table, it's about the size of a suitcase, all right? About a flat rectangular suitcase. And you pop the keyboard out, and it had a little 5-inch monitor, monochrome monitor, and two 5.25-inch floppies, and a whopping 20 meg hard drive, which was big in those days. And I had, I think, 2 meg of RAM, that memory, and that was it.
Was it a
And I was like totally excited. Do what?
Was it a 5150?
It was a 5150, yes.
Lovely.
Oh, and I want to, if you ever find one, by the way,
Oh, they're worth a lot.
yeah, if you ever find one that's not real expensive, let me know, because I'd like to get another one. I have one already, but I want to get another one. Because just so you know, one of my other passions is when I do retire one of these days, I'd like to create I'm gathering stuff for a museum, kind of like for,
cool.
yeah, and so that'd be cool, a working model of that. So that was my first laptop, and dial-up was what we used for modem. And, I carried it around for work and things of that nature, and played, did play some games on there. And everything that we did in word processing, WordPerfect was all in DOS and had no point and click mouse at that time. It was before Windows 3.1. It was Windows 3.0 and Windows 2.0, which was really just a black screen that you could have different menus to do certain things. And you had to type in numbers to get to certain menus, and that was it. So that's a standalone computer I'm used to. Most of you are used to your home, a laptop or desktop, but even then, that's really not standalone, because you're really, most of you connected to a cable modem, or you're connected to a network, wireless network with your computer, and that's technically a networked computer in the true sense of the word. So most people aren't really using any standalone computers today for the most part, but there are a few that you might find, or you might have some off the grid totally at home, an old computer you use for whatever. A lot of manufacturing firms here in town, or even medical research and development, have old computers that are off the grid, they're not on the internet or network, that run old software that would be considered a standalone. And so when I say standalone, it only is local only. There's no networked cables plugged into it, no Cat5, no wireless, no Bluetooth, nothing, all right? And it's using local software, operating system, software, and that's it, all right? Advantages of networks over standalone is, in standalone, if my computer is the only thing I'm using and it's not connected to anything, and the hard drive crashes, my data is gone, right? It's corrupted, say it's corrupted, it's gone. And if I've not backed it up, I'm really SOL, right? And so with a network, though, one of the benefits of networks is sharing. Major benefits, sharing data. When I'm on a network, I can share my data on a network that's backed up incrementally and daily. That way, if my computer dies that's connected to the network, no big deal. I can just get another computer and install my data. I can always reinstall operating system and software, but once I lose data, it's gone. And what I mean by data, like Word documents, databases, drawings, whatever it is my job is, okay? If you're a videographer, your videos, your audio files, things like that. Pictures if you're a photographer. And so device sharing saves money and time, because like I just said, if you have a list of 20 clients, 20 computers like in here, and you're all sharing data, and I'm a server up here, if your computers crash, worst case scenario, we get another computer in there, load the operating system and programs, but you still haven't lost your data, okay? And you can get it right up and running in no time. Central network management is another benefit, meaning I can be anywhere in the world and centrally manage your computer from a network standpoint. I can log in from any tablet, phone, if I have the right software I'm connected to. And I can do updates. I can take over a computer on the network. I can do a lot of cool stuff. I can update software on the servers. So I can centrally manage things, which you can't do if all these were standalone computers disconnected from the network all by yourself. Couldn't do that. You have to go one by one to each computer, do updates and fix whatever and all that good stuff. And so network management is a huge benefit when it comes to advantage over standalone. So some of the types of networks, models of networks vary, like where the computers are positioned. If you look, anybody taking a class in some of the newer classrooms in this building? Anybody taking a class? Okay, you know how they kind of position the computers in their classrooms are different for NIU. They kind of do things a little different as far as the makeup, where students are kind of facing each other and computers are turned in certain, you know, more of a kind of a group type of scenario. Control levels over shared resources is another model, meaning I could have this side of the room, we'll say you're marketing, this side over here is sales. When you log in over here marketing, you can't see any folders or files that sales accesses, and vice versa. Sales, when you log in, can't see marketing stuff and can't access them. Communication and shared resource schemes. There's an item in networking called Active Directory, a service called Active Directory, which we do teach here, by the way. Stephanie teaches that. I do recommend anytime it's offered. It's a small number course, meaning 6 to 8, 9 students take it, but it's a really good course on Active Directory, which is basically the guts of a network and managing a network and sharing resources and security. And with Active Directory, fits right into communication and resource sharing. I can manage groups of users through Active Directory to suck down the rights to that computer, wherever they're at in the network, regardless of where they log in, to what they need. Whether it be programs, whether it be software, whether it be files, whether it be data. And so they can move from one computer to the other all day long, and they're going to have the resources they need. And as administrator, I can log into any of those clients as well and have all the things I need, regardless of where I'm at. So network models would be peer-to-peer, and that would be if I came to you right now with my tablet or my computer and connected a wire in between the two. We'll say we could do USB, which everybody's familiar with that. We could share files on a peer-to-peer type of scenario with a USB cable. Same, I could unplug your Cat5 from your computer, plug it in mine, and we could share data that way with just a Cat5. Wi-Fi, if you have a laptop or tablet, we can connect each other through ad hoc and share files that way, wirelessly. Client server is where you guys are the client in here, and the server is in the other Cisco lab. So when you logged in tonight, you logged into the Cisco network, which is in the other Cisco room, all locked up in the corner there. And so when you logged in with the student account, it recognized your computer, your IP address, which we'll find out what that is this semester, your MAC address of your computer, you'll find out what that is. And so you're logging in, and now that server sees you, it knows the health of your computer, it knows the activity, and it can control a lot or little, depending on the network admin, what they want to do. So peer-to-peers are good for direct communication, as I mentioned, and peer-to-peer in most computing today is done by mobile, peer-to-peer. Meaning we can be in a meeting, I can throw a file to you on a phone or on a tablet or on a laptop or whatever. And I can do that via Bluetooth, which would be the easiest to do with no wires whatsoever. Problem though with sharing though is I have to share a folder if I want you to see it. You don't automatically get that authority and that privilege. Same with you though, you have to share a folder with me on your computer if you want me to see it. May prevent access to resources, depending if I'm not there if we're on a peer-to-peer only in our business and I don't show up that day because I'm sick and all the data is on my computer that you use for your work, can't work. You have nothing to work with. Traditional model though, peer-to-peer is generally 2. You could have up to 3 to 5, capable of sending and receiving information from every other computer. And when I say you could have 3 to 5, you can have more than that. It's just not manageable beyond that. It's just really hard to manage beyond that. So here's an example of a peer-to-peer type of network, and you can set one of these up. All clients, and it can be done wirelessly. It can be done wired, be done through Bluetooth. And once you're peer-to-peer, you can again share files back and forth to each other, share folders. But if one of those computers is gone, we'll say, this one here is your database and they're gone that day, or it crashes, these other two computers here have nothing to work on. And that's the danger and the downside to peer-to-peer. Advantages, it's simple, less expensive for sure. Disadvantage, not flexible, you can't grow, it's not scalable, not practical for large installations, as you can imagine. Resource sharing, it's a user responsibility to share the resources. It's not centrally controlled. Everybody controls your own computer to share with other people. Environments I've seen this in, and does work, is small offices, home use. If you're wanting like a quick sharing scenario to share a file or something. Here's some popular large internet peer-to-peers you might have heard of over the years. Ganella, Freenet, Napster, BitTorrent is all popular, and these are all peer-to-peer type of technologies. The last one, BitTorrent, is used pretty much across the spectrum now from all companies, Microsoft, Facebook, Twitter, any files that people have you download now, Cisco, it uses BitTorrent to do it. And it's a real efficient way to download files. And what BitTorrent basically does is you have one source file on the network, and we'll say it's out here in the cloud somewhere. We'll say it's a 1 gigabyte in size, pretty good size. And the way BitTorrent works is that file is on multiple computers throughout the world and multiple servers. It's just duplicated 1 gig. What happens is when you download a BitTorrent client, it seeds all of these sources and figures out the fastest connection, and it can suck all those files down and put it all together in one final package on your end. So it can literally be thousands of different sources from one file in all these different locations, and BitTorrent's smart enough to manage it, but it is peer-to-peer, and you're sharing files. And again, peer-to-peer can also be a danger because you don't know what you're connecting to sometimes. Not in the case of Microsoft, but really like, say, some of these peer softwares up there, like Ganella is a popular peer-to-peer where people download pirated music, movies, things of that nature, and you can get a lot of bad things in that, viruses and things I definitely don't recommend. Besides being illegal, it's very bad for your computer, okay? Legality aside, it's not healthy for your computer. And sometimes that argument is the only way I win students is when they realize, oh, it could crash my computer. Okay, I won't do it. If it's illegal, no big deal. But if it's going to crash my computer, nah. It's funny. I've taught high school for years, and this one student was downloading some movie over the weekend, told me about it. I said, well, how long did it take you to download it? He goes, it took about 26 hours. I'm like, wow, that's pretty good. I said, so let me think. Do you have a job? He goes, nah. I go, well, okay, let's figure it out. If you had a job and you say you paid $10 an hour, and what's 10 times 24? It's $240. I'm like, well, how many hours would you have to work to get the movie that took 26 hours? About 2 hours. I'm like, huh. So you could just work 2 hours and go buy the movie legally versus spending 26 hours downloading it? And he goes, yeah, that's pretty stupid. And so, they spend so much time downloading, they could just get a job and get it the right way, legal, right? So anyway, I thought it was funny. But anyway, getting back to what I was saying, peer-to-peer is definitely popular when it comes to small office. And I do, talking about file sharing sites that you can get pirated things from, definitely steer away from them because, again, it can, besides the legality things of what I mentioned, it can really junk your computer up. The most junked up, bad computer I've ever seen and the worst health was those who use peer-to-peer software to download stuff they shouldn't be downloading. And so, next with client server, the server part is communication and resource sharing. So when you logged in to the network tonight, you can also go in and see other computers in here, the server itself, and we could share files back and forth to each other. Clients, that terminology is what you're in front of right now, the client computer. Might also be known as a personal computer or workstation. Central resource sharing is controlled by the computer, the server operating system. like data sharing, data storage space. So I could give everybody in here a certain amount of storage space on a personal drive when you log in. We'll say you get 20 megs or 20 gigs, whatever it is we decide you to have, you can have that. And most of your workplaces, if you log in tomorrow morning, you are allotted a certain amount of drive space, personal drive space for your personal drive on the network. And that's pretty common. But no direct sharing of client resources is recommended in a network. It's not saying you can't do it. It's not recommended because the whole benefit of a network client scenario is all the data is on the network. When I mean data, critical data is on the network, right? Because the network data is backed up all the time, every night. You're like here on campus, we have about 12 different backups on a daily basis, and they're all stored off-site at the end of the night. A person picks it up, takes it off-site. That way, God forbid, if we had a catastrophe on campus and everything burned down or was blown away or washed away or whatever, we could literally be up in 48 hours, student database, the entire thing, off-site, source, OD set. We go through a yearly emergency disaster thing. And so if we didn't have a network and backups, we couldn't do that. And so networking helps you keep things safe. So computer roles, server, talked about that already. Clients running local networking applications, storing data locally, and non-critical data. Like an example, you're working on a website that is storing information on a web server somewhere, and it might save a log file or something to your computer on access to that website. No big deal. Not going to hurt anything if your computer crashes, the data is still saved on the website. You wouldn't want to work on like a critical Word document or whatever, a PowerPoint on your local, and then your computer crashing tomorrow, you come in and it's gone. All right, you wouldn't want that. So you want to store everything on a network. Using shared resources like shared applications. What I mean by that is you can buy software today on a network client architecture or client server architecture to where I can say, okay, I'm going to give you guys Adobe Photoshop CS, right? We're going to install on all the computers, and I can buy a network version of Adobe Photoshop to where I can buy it by seat, meaning 20 seats, concurrent seats can be connected to Adobe in this room. Or let's say only half of you use it, so only buy 10 seats, meaning when that 11th person comes in, the software on the network knows you've exceeded the amount. You can't get in until somebody else gets out. And so you can buy by seat on networking software that's pushed to the clients, or you can buy what's called a site license, which we'll talk more about this semester, what that's about, which is more expensive generally. But if you're a larger company that has a software that most people use, it's probably more feasible to do the site license. Servers also are intermediary devices between you and the file server, which we'll talk about in a bit. And the file server is where basically all the files are stored. Okay, so it kind of, the network manages you, the client, and where the files go. It's kind of a middle guy in the network. It's called middle tier technology or middleware. You'll hear that term this semester. Communication, routers and switches. In the back of the room, switches. Up here at the front, that little PIX router, that little blue box, is used in networking all the time. And switches, its job is to take a port on that switch and map it to your computer, and they are mapped by numbers generally and letters, and they can tell exactly, like most of your monitors have like a little number or letter on the upper left corner. If we go back to the switches, we can actually find it in the switches where that is plugged in. And then from the back of that, it comes up here to the PIX router, and then from the PIX router, the cable running on the floor into the IT server room. So here's an example of a common, graphical interface or view of what we've been talking about. You have in the middle some connectivity device, okay, some switch there in the middle. It could even be a hub, which we'll talk about this semester what that is, a dummy hub. You're just connecting all the computers to that connectivity device to where they can share files, they can talk to one another. You'll notice on the upper right corner, though, is the server, and that's the part that the clients, the two workstation clients, log into the server. once they log into it, they can get files, they can get apps of whatever type they need. And then if they want to print stuff, the server client architecture also allows them to print to a network printed service over here. Okay, generally a Cat5 cable runs to that as well. And you can, anybody on the network can print to it if it's set up correctly by IT. So server requirements. You do have a different operating system in servers than you have on your, like Windows 10, most of you have, I'm guessing, at home, or Windows 7, right? If you're PC users, Mac OS. And so a network operating system is different, though, than a client operating system like Windows 10 or Windows 7, because it manages the client's data and resources. So it manages everybody on the network, basically, where you're at, what you're doing, how you're doing it, what you can see, what you can't see, how it's backed up, how you can restore it. It also ensures authorized user access. On a network, I can map off and block off certain times to where you can only access the network during these times. You can only log in from 9 a.m. to 5 p.m. If you try any other time in that range, Monday through Friday, you literally can't log into the network. You can set that up on a network. So I can authorize you as a client when you can access. And also I can authorize you what folders you can see or can't see. I can control file access from a network perspective in an operating system. You can't do that on a Windows operating system natively. Restricting user network resources like printers, file servers, which we'll talk about this semester, switches, Wi-Fi access, the ability to do a number of things like install software. You can limit that as well if you want to. Dictating computer communication rules. I already mentioned that about the time, when you can log in, when you can log out. Now, most network admins don't enforce that on a network server, but you can. There are some places that do, like military installations definitely do use that because they're only regimented on when they can log in and log out, and nobody should be in but certain individuals during other times. Supplies application to clients. You can push apps to the client, all right? And there's things you'll hear about this semester like thin clients and fat clients. Thin clients is where I can push an entire app to your computer that's running on an operating system like Windows 7 or Windows 10 from a server. And an app would be like Adobe CS that I mentioned earlier. Or it could be, another one would be Quark Express, which is a desktop application. Another one, AutoCAD. They have some clients that you can push out through the server there as well, which is engineering software. But also, you can, on a fat client, I can actually push an entire operating system and all the apps to everybody with a proper setup from a server. Like, has anybody worked in retail before? Like sales, retail, like Sears, whatever, JCPenney. Well, when you work in retail, you have the little dummy terminals, right, and a keyboard, mouse. There's really no computer, though. You usually have a little black box that's connected to that whole thing. So you got a little black box where your keyboard, mouse, monitor plug into it, right? You have no USB, you have no CD-ROM, nothing, right? That's actually what I'm talking about earlier on the fat client. It's pushing everything to that device. And the server you're actually on might be in California. It might, if you're working for Sears, it might be in California, and you're logging into a server there to do all the POS and point of sales type stuff. And you have really nothing you can install. It's actually all enforced by that network that it's being pushed from. So server examples would be, this is operating systems, server operating systems, Unix, Linux, Microsoft Server, Mac OS. Those are the operating systems and networking. The top three would be Linux, Microsoft, and Mac OS. Unix is still around, but it's not as popular as the other three. Okay, and we'll play with all three, by the way, this semester. You will get a taste of Linux in here. I'll give you some Linux distributions, live distros. You can actually just put on a DVD at your computer at home and run it as is. Just run a live demo of Linux, and it doesn't install anything, and you can play with it. And you'll even play with Mac OS too. We'll have one of the labs at the end of the semester where you'll install users in all three platforms, Linux, Microsoft, and Mac server. So server features relative to client features, you have more memory, processing, storage capacity. An example, most PCs have a max of, let's say, let's say 24 gigs. You have a really big memory allocation for your computer, and servers though can have 24 times 12. Literally, you have 12 processors. Each one of those processors times 24 gigs. It's a lot of memory. And some of these servers, when you pop them open, have multiple processors, up to 24, sometimes more, depending on the brand you're buying. And so you're taking what you have at home or what you have in your office right now and multiplying that times 18 to 24 power. That's a lot of power. It's a lot of juice. It's a lot of energy. But you're also connecting, though, on those servers, hundreds of users, thousands of users sometimes on a daily basis, doing a lot of processing. So it takes more power to control that and to manage it. And more memory and more processing and more storage capacity. It's also equipped with special hardware like network management functions like I talked about earlier, Active Directory. Active Directory is native to a network operating system. It's not on a client operating system like Windows 7 or Windows 10. And with Active Directory, which is probably the most powerful part of Windows Server, you can literally control everything on your network with that. And you can also lock everything down, lock yourself out. I've done that. And so, it's a pretty powerful piece of software within network operating system. And we'll play with it a little bit. On your client computer in Windows, there is a network management module that's kind of like a 1/1000th of what you can do on Active Directory. But we'll play with that a little bit this semester so you kind of feel around what you can do on your own computer to lock stuff out or to block people from doing things. If you have kids or if you're in a network environment or a computer environment where you want people not to install software or you want them to go to certain websites, you can do all that through your computer management on your computer right now. Most people aren't aware of that, but you can. Disadvantages relative to peer-to-peer, as you can probably imagine, is more complex and maintenance out the wazoo all the time. You can't just let it sit there and it's just going to, install the network operating system, plug in some wires and the switches and routers, and everything just works. Doesn't happen. It's a lot of work, all right, a lot of work. And tonight what we're going to do in just a second is the beginning of that work, which is just figuring out the mapping of our network, how it's going to look on paper before we ever buy any computers, buy any servers. It's a real important step because it is pretty complex. Kind of like before you build a house, you need a blueprint, hopefully. If you don't have a blueprint, unless you're a genius builder, probably not going to turn out too well, all right? And so I was in construction, going through school, and if I didn't have a blueprint for something, I was lost. I had to have a map for everything. I'm still that way, even driving. If I don't have a map of some type, I'm lost. And so I'm a big GPS guy, and so yeah, that's me. And so, but even before GPS, though, it was the Rand McNally map. I mean, that's what I use. And so, same thing though with networking. Though, one of the advantages is it is more difficult to set up, but once you set it up, it's definitely more powerful, more manageable to function. Advantages on peer-to-peer as far as continuing on. User credentials are assigned from one place, which would be Active Directory on a network server. Multiple shared resources centrally located. So I can have everybody in here connected to one file, one network, and one network only, and manage all your authentication, where files are being stored, and things of that nature. User response time is optimized because you're working with a pretty powerful computer, a server operating system, and things get done faster. Things can get done quicker than a standalone. Efficiently processing things on a larger network, sharing multiple files and gig size across a network can be done pretty quickly, and it's scalable. You can add more computers. You just say we're going to build a new building. We just throw in some more switches, We'll run some cabling over there, and we install the computers, and we're up and going. It's popular in medium to large scale organizations. I would say 10 or more, 8 or more, roughly. You're gonna need a network. PeertoPeer is not gonna work beyond that, or less than that. So some definitions, we just went over that. Now we're getting into what's called LAN, MANs, and WANs, and then we'll do the lab. So a LAN is a local area network. That was one of the survey questions last week, which most everybody got right. I try to come up with some pretty ingenious words for those, but I don't think I did too great. So anyway, local area network is what it stands for. It's a network confined to a relatively small space. So in this room or in this building, we have multiple LANs. Each classroom could be considered a LAN. It began in the 80s, and it became popular as time went on. Today, pretty much every medium to large business has, even home users have some type of LAN. The next one's a MAN, a metropolitan area network. This is where the network extends beyond the building boundaries. So in this campus, we have multiple buildings. We have our building here, WTC. We have the PEC, ERC, JCSM, the maintenance building with the police. All these are interconnected with tunnels underneath the campus. And the tunnel's actually big enough for a golf cart to go through. And all the buildings are connected with fiber underneath the tunnels. And each building has a drop box in the tunnel where that fiber comes into it. And from that fiber box, the switches are started in each floor. Okay? When the buildings were first designed, we all had these little gray boxes. The new building, JCSM, does not have. All the wires and all the switches are under the floor, and you don't see them. But this building here, I think CO1, CO2, you can still see these around. But the tunnel's kind of cool. And that would be considered a MAN. And in that tunnel, by the way, they do have to paint it once a year. And they literally use a golf cart and put the paint on the golf cart. And they have painters that go down the tunnel, through the tunnel, and do any painting or updating that might be needed in the tunnel. So MAN would be that type of scenario. So multiple LANs within this building, connecting buildings together, MAN. Next would be WANs. WANs is actually taking this location on Mulford, which is the main campus, and connecting it to Stenstrom and to Bell School through what's called a WAN connection. Anytime you hear WAN connection, you think of internet. Okay, that's all you think of. And internet can be connected through the WAN. We can connect through direct connection. Like we can have a direct connection through AT&T from this building to Stenstrom and pay big bucks for it. You can definitely do that. But you can also use the infrastructure of our ISP provider, our internet provider, which is Illinois Internet that we use. We write like a $2 to $3 million grant each year to pay for super fast internet from to have 2 or 3 T3s, T4s connect, which you'll learn what that is this semester. And basically what happens is, we'll just use this router in this room as an example. We'll say this is the router for the entire college, which we do have one, by the way, a main router that hits the outside campus, outside the building. So from that router, we'll pretend this is it. There's also a router in Stenstrom on the left. There's also a router, we'll say, we'll put a router on the right here, even though there's not one there. And that right of that middle router. And we'll say there's a WAN connection there, maybe to the Bell School campus. And that WAN link, which is a lightning bolt, is basically just connecting the two together using the current internet infrastructure, your internet service provider, whatever it might be. And so WAN connections are very popular in businesses like Sears, JCPenney, Pepsi, Coca-Cola. Coca-Cola company here in town, which I worked for Pepsi for years until I busted my back going through school. Well, actually, Pepsi is what caused me to go to school, because when I busted my back, I couldn't do manual labor anymore. And so I had to switch careers. But when I worked at Pepsi in Joplin, Missouri, they had a direct line from Pepsi in Joplin, Missouri, network line through AT&T to Tulsa, Oklahoma. Tulsa, Oklahoma. That's quite a distance, by the way. It's about a 2-hour drive, roughly. But literally had an over-the-line telephone line wire from that building to the Tulsa plant, the company. And that's where Pepsi is located. The mothership is in Tulsa, Oklahoma. Same thing here in Rockford, though. A student, one of the labs you do at the end of the semester is you call local businesses to figure out what their network is comprised of. A student called Coke here in town. I think it was there on Forest Hills. Forest Hills has like a Coke distributor, kind of a little old brick building.
It's on a side road.
Yeah.
Along 251.
By the old bubblegum plant, or bubblegum plant
they
there.
have a trucking facility.
Yep. And it's just a place basically like the Pepsi plant I worked at. Trucks pull in the morning. My job was to stock the trucks with the pop for the drivers, basically. And but they have a direct line from that Coke plant here, that Coke distributor, to Madison. Madison has a big Coke distributor. That's one of the main buildings in Madison. And so you can have that, or you can have like this picture shows here. You're using any ISP that you're working through. And most home users or most small businesses are going to do that. Like here locally, it'd be Xfinity is what businesses are going to use, because that's really all that's out there right now that's of any speed would be Xfinity that they would use for business use. And they could connect to their corporate through Xfinity, and using routers on both ends, you can directly tie in, you'll learn about this semester, IP addresses on both ends to be able to talk to one another. So literally when I log in from Madison, or vice versa, log in from Rockford, I can talk between the Madison and Rockford plant, can share files just like they're in the same building in a WAN connection. So wide area network is what that stands for. It's comparative to a LAN, but over a large geographic difference or range. So here's an example of a simple WAN with the WAN link in between. On the left and right is both normal network LANs connected to client-server architecture. So to end, the client is a network computer requesting services from another network computer. Client workstations generally have a human user, or maybe today's culture, maybe robot. I don't know. It could be a robot, half human, half robot. I don't know. We had some show coming out with robots. Client software installed on the workstation, like Windows 7, Windows 10. Server, network computing, managing resources, runs network operating system. Or the workstation, which is today's vernacular, would be the same as a client, may or may not be connected to the network. So, do you guys want to go on to the lab, or do you want to take a break? The lab's going to take about 10 minutes, 15 minutes at the most.
By the way, I think the internet connection here just went out.
Oh, it did?
Yeah.
Well, I'm glad I had you guys submit the lab earlier. Submit your name, all right?
Yeah,
All right.
That got submitted, but it just went down out of nowhere.
Okay. Well, then, do you guys want to go into the lab, or you want to take a little break? It's up to you. How many wants to take a break? All right, cool. Let's do it. Let's go right into it. I'm going to stop.